I did not hear, yes. Thank you. So, just the last thing I did not show you last time, and you have homework on that. Isn't it interesting? In 2D, we only had two cases with lines. Lines are either intersecting or they're parallel. And in 3D, two of those intersecting lines, and then push them away from each other. Now they don't intersect, but they also not parallel. How cool is that? So 3D definitely gives you more space to work with, and that's okay. And that's what they call skewed. Not how we call it in Russian, but kind of interesting idea that they can be not parallel, not intersecting in finger. That's skewed. And then I like, oh, isn't how you guys call skewers? This is a genius picture I found. I'm proud about it because it has all three cases: parallel in 2D, intersecting in 2D, but also if you lift this one up and it is lifted, then these are skewed. Pretty cool.
What's the ingredients?
That was a mushroom.
Mushroom.
Yeah. So that's going to be in your homework. And now guess what? When you have a system like so, and they ask you which one is that, parallel, intersecting, or skewed, they basically very easy way of thinking about this. So you check if they're parallel. Who remembers how to know if two lines given in the form of the system are parallel? Yes.
If their vector components are multiples of each other.
Yes, you should look at the number. Thank you. Exactly. You should look at the numbers, and you will see which ones here. Which one are you talking about? These ones or these ones?
The one with t.
The one with t. Remember, the one that's multiplied by a parameter is your slope. If slopes are multiples of each other from here to here, then these lines are parallel, right? So 1, 1, 1. 2, 3, 4, no correlation. These are definitely not parallel anymore. And then if they're not parallel, there can be two cases. They are intersecting or they are skewed. To do that, to check this out, you need to see if there is a solution. So if equations can be solved, then there is an intersection point. When you solve the equation, if it gives you some kind of weird stuff like 3 equals 5, like no solution, then they are not intersecting but not parallel. Pretty cool idea. So imagine in 3D we already have such a cool case. How about 4D and 5D? That is even harder to imagine what is happening there. And we're going to go to upper dimensions in the middle of the class. So that's going to be pretty cool. We will work in 5 and 6 dimensions. Be ready to go up and beyond. Equations of the planes. That is the most interesting stuff. So again, we're doing baby steps right now, like in pre-calculus class, or even I would say algebra class. Baby steps where, look student, this is called a point, 1, 2. So that was like the first step, to teach people what point is. The next step was like, those are 2 points, between them there's a line, and then we did this equation for the line and stuff, so very baby steps. Then we did parabolas and stuff. In 3D, plane is the next step after the line. And then what do you think goes under the plane? Whatever is plane but not flat, that is a curved surface. The surfaces, not only nice surfaces like a sphere, but just random surfaces like floating roof and so on. That will be also pretty interesting. So we're still doing baby steps, we're still learning flat things. And this is a plane. The most important object in multivariable calculus is a plane. The equation of the plane is ax plus by plus cz equals d. In some literature, you see it minus d on the right-hand side. Same thing, doesn't matter. Now, let's see why and how should we find it. What defines a unique plane? For example, let's try to sketch the plane 2x plus 3y plus 4z equals 0. So d is 0 here. Right? Let's try to sketch that. I have A is 2. Well, I can do like this. A, B, C, and then D is 0. That's what is going on. So if I plug 0, 0, 0, why it's red. If I plug 0, 0, 0 point, it gives me 0 equals 0. So 2 times 0 plus 3 times 0 plus 4 times 0 is 0. Thus, this point O which is center, the 0, 0, 0 point, belongs to this plane. So, first of all, now we know it goes through 0, 0, 0, the origin. Second thing is to notice, how can I rewrite 2x plus 3y plus 4z equals 0? Look at this, and this is kind of the most important thing you should understand. We can rewrite like so. Rewrite 2, 3, 4 a vector times x, y, z a vector equals to 0. So this, if your brain can get used to this idea and be fine with it, that's what I just did. I rewrote this. This leads to lots of engineering and physics, building machines and constructing buildings and so on. Such a simple idea. Do you all agree? This is product of 2, 3, 4 times x, y, z. What kind of product is that? Dot product of what?
Two vectors.
Two vectors. So you see, I gave you equations and somehow we jumped to vectors. How is that possible? But then the most important thing, I just from nowhere found vectors here. And I rewrote it using vectors. Vectors are tools I'm going to be using to fix this plane. So the plane is just a set of all the points. Set of all the points. Going through GH, going through the origin 0, 0, 0, and notice the most important part here. What does this mean? That the dot product equals to 0. This is going to be on the quiz today, by the way, this question. What does this mean? That there is a dot product of two vectors gives you 0. Perpendicular or orthogonal, correct, right? So you remember that. That means this vector, let's see, this vector is perpendicular to this vector, right? Because the product is 0. Which kind of product? That's important. Dot product gives you 0. That means two vectors are perpendicular. Now, before I finish the sentence, look at that. So I will take a random paper. Well, it's not random, but it's fine. Here's the paper. This is the plane. It's floating in the air. Let's fix it. So all infinitely many different planes. For now, we only know it goes to the origin. Fine, I fixed the point. Now it goes to the origin. But through the origin, it can go all kind of directions. What's one thing that can fix the direction of the plane and make it unique?
Another point?
Another point, not really. Another point defines a line. So now to this line, it can go all kind of ways like this. So that's actually also not enough. But you're close.
2 points.
Orthogonal vector and also correct 2 points. Plane is defined by 3 points. The moment I fix 3 points, now it's fixed, right? That's it. That is correct. We're going to do it later. Orthogonal vector is coming from this idea. So this point is fixed, and this orthogonal vector gives me the direction. So the point is fixed. The moment I cut it with orthogonal vector, it can't move anymore. That's it. Because there's only one plane that's orthogonal to this vector going through the given point. So that was your quiz. Put it back. So not only going through 0, 0, 0, but it's also perpendicular to a vector 2, 3, and 4. And that vector just came from A, B, and C. And that is what creates the equation of the plane. Here's the picture. The plane is going through 0, 0, 0, and it has an orthogonal vector n. We're going to call it n all the time, so that's going to be a very standard notation. And that fixed the plane. This plane is unique. So A, B, and C came right from the equation. So kind of that's all. The moment you see the equation ax plus b, y plus cz equals d, you immediately know what the plane is. Yeah.
And then, so as long as you know one point and the vector,
Yeah. It defines a plane.
Okay, and you can find that point because you can set the equation to 0.
Yeah, and not only to 0, you can solve. You can try to plug anything that works. We're gonna do this too.
Well, other than guess and check.
Yeah, exactly. So this vector n, which was 2, 3, and 4, and came from those numbers 2, 3, and 4, is very important. So we made a name for it, and we call it a normal vector. A normal vector, which basically a vector that is perpendicular to the given plane. Definition: a normal vector ABC is a vector that is perpendicular vector to the plane AX plus BY plus CZ plus D equals to 0. So you see these A, B, C's are coming from the equation. Thus, the general equation of the plane is generalized by the point and a normal vector A, B, and C. That's what they call a linear equation of the plane in X, Y, and Z. If A, B, and C are not all 0, then the linear equation represents a plane with a normal vector. And that's kind of too much information. This is very good. Redundant. That was the word someone reminded me after the class last time. I wanted to say that's it. Why do you keep repeating this? Redundant. So let's see. A normal is a synonym of being perpendicular. So if someone's saying, "Are you normal?" You're like, "I'm perpendicular." There's lots of jokes about this. Lots of memes about being normal means perpendicular. So it's precisely this fact that allows us to easily find equations of the plane. Let's find the equation of the plane. Here's example. Going through the point 1, 2, 3, and already a given vector n. Let's draw a picture. I want to teach you that it is not as scary as it looks. So let me do it by hand. I'm drawing a plane, some kind of plane. You just make a piece of paper like so. And then put that point randomly somewhere. So you don't even have to do this 3D coordinates we did before. 1, 2, 3. Just randomly put a point. That's what usually people do. 1, 2, and 3. That's a point with parentheses, you see? And then there is also a vector that is perpendicular. It's called normal vector n. So I do brackets 4, 5, and 6, like so. This is perpendicular. This defines the unique plane. We sketched the graph, but we need to build the equation. But does it make sense? I sketched it. Plane, a point, and a normal vector. Yes.
And you also work with parallel vectors?
Yes, a good point. If we work with perpendicular, from there we can switch to parallels instead, because they relate, and that's where the cross products will come in. So that will be in the future. Very good idea. And that's where the 3 points are also coming. Of course, parallel vectors also define the plane. 3 points define the plane. But it all started with this. That the plane on a piece of paper is fixed by a point that cuts through and a perpendicular vector. Everything else follows from this. So the idea is this vector can be shifted here and there, right? So I don't actually necessarily having it at this position. I can easily even move it to this point if I want. Doesn't really matter. The most important is that I immediately can build the equation. The equation of the plane solution will be, so which numbers I need? Remember that 4, 5, and 6 were the one that we're multiplying here. A, B, and C. That's what we did. Now, since it's coming through a point 1, 2, 3, x minus 1 should give you 0. So that's how I know it should be x minus a, right? Then y minus 2, and then z minus 3 equals to 0. Is this the same equation we defined as ax plus by plus cz plus d equals to 0? What do you think? Is this the same thing?
Yeah.
Yes, because
just shifted, right?
it just shifted. Moreover, if you distribute all those numbers, 4 times minus 5 times minus 1, 5 times minus 2, 6 times minus 3, they will accumulate into d. And that's what this d means. D accumulates the shift. And we actually can do it if you want. if you distribute, sometimes we ask you to do it, sometimes not, 4x plus 5y plus 6z, do you see what I just did? I know what's important. The variables important, so I just kept them. For now, 4x, 5y, 6z. And then, sometimes people either do equal sign and move d to the right. That's a very common thing. Or they keep it here. D will be, what is that? Minus 4, minus 10, minus 18 equals to 0. So that's exactly what my d is. And this number represents a shift, some kind of shift. But remember that 4 and 5 and 6, they represent the perpendicular vector. And then point allowed us to guess the shift. So all we need to know to find and fix the plane in the universe is a point and normal vector. Pretty cool. Does it make sense? So this is very nice. These questions are very good questions for the quizzes and exams. For example, how about 3 points? 3 points also fix the plane. Do you believe it or not? Let me check again. I don't know. Let's check. So 2 points. 1 point here and 1 point here makes a line, but in 3D plane can just roll over the line. So that's also not very unique. The moment I fix the 3rd point here, the triangle fixes the plane because triangle is a plane, right? Triangle is already representing a plane. So the moment you put 3 points, done, the plane is fixed. That is also pretty cool. Thus, it's actually enough information to build the plane. Let's check that it's true. Here is the plane, like so. And I'm putting those A, B, C's here, A, B, and C. They have coordinates. I don't have to rewrite them. So you see, we're going, the more you go to the upper level maths, the more vague everything becomes. That is why the stereotype of mathematics is so precise and not creative at all. It's lame and wrong. The upper level math tells you how creative and vague everything is. See, I don't even care to put numbers in. So sometimes they call us sloppy, the upper level mathematicians. We skip lots of numbers, which is like, it's B, who cares what numbers are? But that's exactly what makes you understand the big picture versus the details. That's why there's a joke that the more math you learn, the harder it is for you to calculate tips in the restaurant. It's somehow like you're going away from the calculations to something very deep and 5-dimensional, it's 7-dimensional. So, step 1, choose the point. Choose the point. Because we need a point and a normal vector, right? Let me write down this for you. We need a point and a normal vector. So let's choose the point. Doesn't matter, any will work. Just fix the point. For example, A. Why not? So A is 0.212. That's where also creativeness comes from. We just need to fix some point and we're fine with that. Normal vector 2. Normal vector. So now we need a normal vector. We just need to choose how to even create normal vector. Remember, normal vector is sticking out from this plane towards you or back. How would you find it? Anyone else have ideas? Yes.
To make vectors AC and AB and then cross product.
Yes, amazing idea. Can you explain? How do you know? So I will do what you said. AC, AB, and then what did you say?
Cross product.
Why cross product will give me a normal vector?
Because it's perpendicular to both of those vectors.
Yes, exactly. Do you all remember cross product gives you perpendicular vectors? That's why we learn it. Cross product gives you a vector that's perpendicular to both AC and AB. It's perpendicular to the whole plane. And that's exactly why we're learning cross products. Normal vector. So choose any 2 vectors. I chose, or you chose, AC and AB. So let's build them first. AC and AB will be, you remember that, so I'll go fast here. -3 minus 2 is -5, and then 7 and 4. Now, -2 and -2, -4, 1 more -4, and -1. We have those 2 vectors ready. And now, This was,
Yeah, they're close. Yeah, they're close. It's
let's see.
supposed to be AB and then AC.
Oh, AC, sorry. Yeah, good catch. AB and AC, let me point it out. AB and AC. That is step A. Step B, let's find A, B, cross product AC. That gives you N, the normal vector we need. Normal or perpendicular vector that we are looking for. And now this procedure starts. You're going to do this procedure for the first problem of the quiz, how to find a normal vector. You remember how to do it, right? N will be, you build this guy, I, J, K, right? You don't have to put it here in the matrix. Minus 5 and 7, 4. Minus 4 and minus 4, minus 1. I'm not reminding this to you because you're supposed to be very good at this by now. And then you build small determinants, and then you calculate, and you will get 9i minus 21j plus 48k. Or you can also write it down in the shorter form, 9 minus 21, 48. Nice. We are almost done, one step away from the answer. 3. The answer is just a part of the formula answer. Remember, so normal, normal, normal. I will just multiply like so. Oh, it's fine. 9 minus 21 and 48. That is my slope or steepness of the plane. Now I will have x, y, and z minus each point. So just this is how you build the equation. And then what are the points? We chose point A. So you can do minus 2 minus 1 minus 2 equals to 0. Many of us like leaving the answer like so. Or you can again do like I did before, distribute and have a nice answer with 9x minus 21y and 48z equals some kind of number. But this is a good one because it shows you the roots really nicely. I see the point, the roots, I see the slope. So you see it's a three-dimensional slope here basically. A normal vector kind of shows you the angle of this plane. It's like so, like so, like so. Pretty cool idea here. What do you think about that? That makes sense? Yes.
So if you choose any point, let's say we chose B, you do that for B, so x minus like whatever the point for B is.
Yes, yes. Any point will work. It will. The math will fix it. So any point should still work. Now, yes.
So no matter what point you pick, you'll get the same D value?
Yeah, definitely. So it will still figure it out when you distribute and multiply everything.
And is the shift from the vector, or is it, what's the shift describing?
The shape describes, no, it's not. Let me see, I'll show you like so. The shift is more, remember when we had in 2D, y minus y0 equals mx minus x0, that was the equation of the line. So that's the same thing, it's a shift of a point, right? Kind of like note. Yeah, hope that answers. I think this is how I would explain it. So any point, you plug this point or this point or this point or any random other point, should still work it out. So these all points belong to the plane, so should still work. Lots of stuff are coming from this idea. The distance between the point and the plane immediately. The moment we fix the plane, now we can find a distance between the point of the plane. And here's the equation. Looks scary, but it's not too bad. It's the marginal of a of x sub 0. Well, just write it down. Too much saying. You can just write it down. So let me do the example with you. Here's the distance. Let's work out the example. Basically, you plug everything right away. There is a derivation of this formula. It comes from the perpendicularity and projection. Someone actually asked today about the projection. The formula comes from the projection. So this is a product of numbers here for you to know, just to point out. A is what is from normal vector idea. D is like this standing alone number. And then you find this size of the vector, right? The square root of a squared plus b squared plus c squared, and so on. For example, find a distance between the point P and the plane. To imagine, it looks like this. The moment we now know what plane equation is, now we can answer those complicated, nice questions. Imagine space science. It's exactly what they do. Here is a floating station in space. Here's a meteor. How do they find distance, and how the distances could change it? For example, certain, unfortunately. How do they find it? They use this equation. So, makes sense that the closest distance will be not this one, right? The closest distance have some kind of connection with the normal vector. So we need, even if the plane is like with the angle like so, you still can find some kind of point, maybe over here, where this vector is perpendicular. So the shortest distance has a connection with the n, vector n, which is normal vector. And that is why it has this a, b, and c in the formula, because that is exactly a normal vector. And that is why it has marginals everywhere, because magnitudes everywhere. Magnitudes are distances, so that's exactly what will give me a finite number, a distance. So here's the plane, here's the point, and the equation of the plane is given. How to find a distance? The distance, let's call d, why not? D will be, the formula says, maybe take a pencil and write down, this is my A, this is my B, this is my C. D is 0, we're lucky. Is it 0 though?
Yeah.
Okay. Then it's going to be, oh, I do have different example here. 2, 3, and 1. Why this picture doesn't match? Oh, I see. My picture doesn't match this picture. Here it is. Okay, so who wants to tell me what's based on this formula is going to be? Just read it out loud.
Oh, so the top half is going to be 4 x minus 1, right?
No, we don't have any more equations.
Oh, just 4.
So everything should be numbers now.
4 plus
Times.
Yeah, well, it's 4 times 1 is 4.
Yes. Now, what else?
Plus 5 times 2 plus 3 times 6.
Plus
Over
0. Absolute values, because we don't care about the sign, remember, it's a distance. Over what the denominator is, square root of what?
It's going to be 4 squared plus 5 squared plus 6 squared.
Plus 6 squared. Anyone calculate it?
The number.
I have a different example here, and that's why I don't see what it's supposed to be. That's interesting. Bless you. Oh, I have it. I found it. It's 32 over square root of 77. Yeah. So 5, 2, 3. Yeah. So find the. It's supposed to be a finite number. You do understand it, right? Because it's a distance. And if you got negative, take absolute value. That's why it's here. And that's why there's a root in denominator. So it should be a positive number. Distance is positive, even if the point is below or above. Yeah, I think it's 10. It should be positive. Now, last comments on this. This is the derivation. It's coming from, we don't have to write it down. It's coming from the projection. That's why the composition component is here. So it's a vector projection, but we don't care about we don't care about direction. So that's why we do component. And then what else is coming? The distance between two parallel planes. That's what you should learn. The cool part is the angle between planes. Look at that. Two angles are cut through with, two planes are cut through with a weird angle. How do you find that? You locate a normal vector for each. Green plane, green normal. Blue plane, blue normal. And then you find the angle between these two. How fun is that? So that will be also pretty interesting idea. And to find this is pretty straightforward because it's 1, 1 minus 1, right, over here. 1 minus 1 and minus 2 over here. And then you find the angle between these two. This is going to be on the quiz right now. How to find the angle. Who remembers the formula?
Is it A times B?
N1 times N2. Size of 1.
Size of 2.
Size of 2. And then cosine or sine? Cosine of theta. You plug in here, right? So I just found N1 and N2. This is dot product. Then you find the size of each, right? Multiply it. And then cosine is unknown. So you're looking for cosine theta, respectively for theta. This is one of the last problems on the quiz today. You have to be good at that. That is the formula of the distance of the angle between, what is this? Vectors. Okay, good. Okay, so ideas of the quiz. We're gonna do the quiz right now. Originally, I usually did people in groups and we do the quiz, last 20-25 minutes of the class, and then you submit it right away. So it's supposed to be stressful and you're like, oh my god, I'm too slow, I'm too fast. But because of the COVID situation, people are getting, they email me all the time that, oh, I have to be isolated for 10 days. It will be too complicated for me to leave them quiz later. So what I'm gonna do is better for you. You're very lucky about this tutorial. So it's the first time I'm gonna allow you to take it home and then finish it by midnight. So we're gonna start right now. Not only we're gonna help you with it, then you're gonna go and find your book and do the quiz perfectly. And then you submit it by midnight, and you better get perfect score because I don't know what else. So
Wait, that was Oscar's grading. We can't get perfect.
Let's have the rules.
Oscar's really nice to us.
So the rules are, you have to write down all the work. I will be grading, she's doing it for the whole year, she knows. If you give me the answer for this, oh, this is 5. That is 0 points. You have to show how did you get it. All the formulas, all the steps, all the calculations are there. No work, no points. That is exactly how I will be grading the exam later. Second rule, you'll be working in groups of people, 4 people or so. You have to help each other. Don't be that smart ass person who's like, I'm down, I'm leaving. No, you have to actually ask, like, who needs help, explain to each other. Also, don't be that awkward person who is afraid to ask for help. It's fine to admit you don't understand, but that's why you have people around you to help you. So this group quiz, this is what a tool I'm using to find future TAs and IAs for our school. So I used to be my students. My other graders are also used to be my students. They found this love of explaining. And then I recommended them for the position, and now they hired for years to be our helpers. So it's very nice to recruit people like this who like helping and who are good at it. Now, do you want to add something about what do you think? No. So make sure your handwriting is okay.
So we shouldn't know our answers.
Make sure your handwriting is good. There is a PDF online if you want to use your Surface Pro or tablet or whatever. And you can find it here.
I had a very slight question though on the answer guide.
Oh, Gradescope, just a second. Gradescope. You will go to Gradescope. It's located over here now. See, it's over here. Now, when you go to Gradescope, where is it? You go to your class and you can submit your work there. To find a PDF file, you go to Assignments. Oh, that's not the right class. You go to Assignments and you see it in Quizzes, if it takes forever. Come on. But I will give you paper if you want. Your job, if you actually cannot print it and you are at home, at least imitate the location of problems, okay? That's kind of the idea. So, yes. You guys are working together as 2 lines of people.
Can everyone that knows each other work together?
No.
Main characters work together.
No. It should be all random.
You know it's not gonna be random after this
You
class.
guys are working together. You should help me.
Yeah.
Oh, you have it? No, I can't. Here. Go, and then the 2 teams.
Guys, we
You
have a
guys are
group
working
chat.
together. Also, try not to like to touch each other. Don't, I don't know.
Wait, are we touching each other doing math? Oh, this is this.
Yeah, just, I don't know. Yeah. Oh, whatever, right, I don't know.